Right, this is our second video in section 4.4, and we're looking at the last example. We were asked to write a paragraph proof, and before we start any proofs, I do like to kind of mark our picture, and this picture has been marked for us, and I also like to kind of think of a plan of approaching the proof. You know, we've been working with SAS and SSS. Use SAS or SSS, they're telling me in this proof. I am looking at a way, and you might find a different way to do proofs. The more practice and the more level of expertise we get in writing proofs, you'll be able to find alternate paths for solving. So if you find one, please let me know. But what I'm looking at here is SAS. So let's talk about what we got. So we're given this bit of information. BC is congruent to DC, and BCF, let's look at that angle. The angle BCF, that's this one marked here, is congruent to angle DCE, this one marked here. And finally, FC and EC are congruent. And so we can already show that these two triangles, BCF and DCE, are congruent triangles, but that's not what they're asking us to find. What they are asking us to find is this, and I'm going to do it in a different color. Let's underline it in green there. They're asking us to find that angle CFE, am I right? No, CFD, which still refers to this angle. This angle is congruent to angle CEB, this angle right here. So I'm trying to figure out how to prove this. And this is a little tricky, but what I want you to observe, first of all, I might ask you a question like this: how many triangles do you see? The knee-jerk reaction might be 3, and then you might say, oh, 4 because of the big one, so you got 1, 2, 3, and then 4. But then I implore you to see that there are more. And the two triangles I want you to look at will be triangle BED. Triangle BED, I'm going to go over it a couple times so that this green is a little darker. Triangle BED, and the other one is triangle FEC. There it is. All right, do you see those two triangles? I think if I can concentrate on these two triangles, this would be good. And I'm about to use something that that I think might be a little bit, I don't think they talked about it, but I'm going to talk about it anyway. Something called congruent parts of congruent triangles are congruent. So my story is this: if I can prove that the green triangle and the yellow triangle are congruent, then I can say that the angles CFD and CEB are congruent parts of these two triangles, and therefore, since they're congruent triangles, they are congruent. All right, go back through. If you got to pause me and say, all right, I wasn't listening to this woman, go back through, listen to my explanation again as we go through this. And so they ask us to do it in paragraph proof style. I told you I'm old school. I prefer two-column proof, but I'll try a little paragraph proof here. So I've decided to start off with the given concept that's most important to me right now. So given that BCF and DCE are congruent, then these guys are equivalent as well, and that we know that from definition of congruent angles, right? So the measures are equal, and so if I tell you that the measure of BCF plus the measure of, now I'm going to add this little angle in here, watch this, the measure of FCE is equal to the measure of DCF. Am I doing this right? Let me see. I said BCF, BCE. This should be ECA. Okay, DCE. Sorry about that. You get what I'm doing, right? Right. Okay, so if I get, and watch this, it'll make sense in a minute. Just be my friend. FCE. I don't know why I'm having difficulty with E's today. CE. Okay. If I told you that these two were equivalent, you'd be like, yeah, and, right? And the reason why, watch this, is because I'm adding the same thing to both sides. Let's make it an E, people. Let's make it an E. All right, so look at this. I've got two measurements that are equivalent, and then I add the same thing to both sides. The reason why I would do that is so I can make these bigger angles and state that they're congruent. And the reason why I'm stating that they're congruent is because then I get to say side angle, side for the green triangle. Look at the green, side, angle, side. And then for the yellow one, I get to say, or orange, whatever, I get to say the same thing, side, angle, side. So the key here for me is to prove, let me use green, to prove that this large green angle here, let me do 2 marks, is equivalent to this large orangey yellow angle here. And then I can prove these triangles that I'm talking about and get the little things that I want to get. So if I say that this plus this is equal to this plus this, that's just from the addition property of equality, because I can add the same thing to both sides of an equation. The next thing that I want to do is point out, okay, so this is weirdly written, but I'm going to go for it. Since BCE, right, since the measure of angle BCE is equal to the sum of this guy, and then the measure of angle FCD, that's this part, is equal to this angle plus this angle, then, and we just said that the sum of those two angles are equivalent, we can therefore say that I didn't say BCF, I said BCE, I think the E's aren't happening for me today. BCE is equivalent in measure to FCD, and specifically that implies that angle BCE is congruent to angle FCD. And now I'm almost home, because what I wanted to do is prove these two triangles congruent, and I'm just going to give this next other information, which says that these two segments are congruent, right? This pair of segments and this pair of segments are congruent, so I get me some side angle side. See it? Side angle side. There, I've said that. I said that these two triangles are congruent. Let me add a little by side angle side, since they asked me to use one of the two. And then finally, I can talk about these two angles. Angle, let me go back up here. Angle, the one that we were getting to, come on, pen, work. Angle CFD is congruent to angle CEB, because you've got these corresponding parts. Of congruent, I'm going to use the symbol congruent triangles. They've got to be congruent. So I'm going to write it this way: corresponding parts of congruent triangles are congruent. And that's my little take-home story there. And yeah, I'm going to leave it at that. And so if you have any questions about this section, this was a particularly challenging proof, and my gut feeling is always to do proofs in 2 columns, just the way I was trained. But no worries, this is a thing. You can do this. I find it harder to follow when it's in a paragraph, also with my handwriting. However, feel free to ask me any questions. Let me know if there's something that we can do that can make things a little bit clearer. I look forward to talking to you soon. Take care. Bye-bye.